spindle frame one. I put it on, had some videos up on it a while ago, and got a lot of comments, um, mostly negative comments about it. And then after they saw the performance, and they started getting more positive comments, there was some that challenged that it, couldn't perform because I had made the statement that it outperforms or equals in performance at the least a conventional motor, the big AC driven ones. This motor weighs 11 pounds. The drive system is off of it now. I've been doing some other work, some tuning, and I cannibalized a few pieces because I didn't have quite enough to make the next sander test bed. I ordered some new pieces that are coming in. They'll be here in a couple days. And so just to do comparison, so to get your actual real comparison, I actually built another sander. Put a 2 horsepower, 3600 RPM AC motor on there with variable speed. Got a K-back variable speed control on it. What I found so far is that the motor, with when I put it double speed and tried to run a 4-inch wheel to get over 7,000, which is where I wanted, the small motor machine will run about 7,200 surface feet per minute, and it'll grind really strong up at that speed. And it's got good power in the other ranges as well, comparable to what work you would do at those RPMs. Obviously, I don't need, and I don't know anybody that, maybe there's somebody that needs tons of torque and power with low belt speeds. I don't. When my belt is going slow, then that's when I'm doing finesse tasks, detail work, fine grit belts, Scotch-Brite belts, belt belts, those sort of things when I'm polishing or cleaning, and I'm not running really high belt speeds. I don't need tons of power either. I'm just cleaning up and finishing up. Where I want the power is up on the top end. Now when I ran this, this is the 5-inch glass-filled wheel from Oregon Blade Maker. When I ran this, the first time I had the motor up on double speed, the motor can't handle it. It can't even handle it when there's no load. It goes up to double speed, and as soon as it hits there, it just starts dying off. And it gets into just like not quite a free fall, but it doesn't just catch itself. It just starts going down and down, and maybe around 50% where it's at its rated power, it might hold there. But yeah, it's completely useless to be operated in double speed with that wheel on it. And then I also ran it with this one on there. This is a 4-inch wheel, and this one as well. It would pull it with no load at double speed. It was 36. So it's given me 7,400 surface feet per minute, and it would hold it with no load. As soon as I put a little load on it, just a small load, it would just start to die, and it wouldn't recover. It just didn't have any torque at all at those speeds, and so it was completely useless for even moderate or light level grinding. I mean, I was just kind of grinding along the edge, and it wouldn't handle it. As soon as something touched the belt, it was over. And so I was pretty disappointed then. That was yesterday. And then today I jumpered it back down to regular so that when the VFD is on 100%, the motor's putting out 3,600 RPM instead of 7,200. That's been a lot better. Only problem, I mean, it has really good power. Then this pulls really well. I mean, you can pretty much put your foot on the belt with metal blank, and it's not going to bog it down. It had a lot of power, but my problem with that is it was running about 3,700 surface feet per minute on the belt. That was its max speed, 3,700. Now, belts like these are Cubitrons. They like to run, or they need to run fast, and with a pretty good pressure, I would say, for knife grinding, if you're doing it by hand, it would be considered a very heavy hand pressure. They're, designed to be run by robotic machines, that sort of thing, that can put on a real constant pressure, and they need those pressures and high speeds to crack the grit, and that's why I wanted to get over, at least over 6,000. 7,000 I've run there quite a bit, and I enjoy that. You make knives fast. Metal comes off quick. These belts love to run up at those high speeds. So anyway, that's where we were at there. That one was delivering. It had good power and everything, but the top belt speed was just not acceptable for me. Then this is the 5-inch. I had the 5-inch wheel on there and did the same thing, and it bumped it up to about 4,600 surface feet per minute belt speed, and it had good power again, and so I was satisfied with the power at the top end. Still, the top belt speed was too low for what I'm interested in. So I've ordered a 6-inch wheel. I'm going to try the 6-inch wheel, which will get me up around 5,600 surface feet per minute belt speed. That's at the very bottom end of what, in my opinion, is considered acceptable for high-performance knife-making grinder. 5,600 for me. I mean, that's like three-quarter speed from what I normally grind at is 5,600. And it's not something that I would do on a regular basis or I would want to own myself. But there are people that 5,600 is as fast as they want to go. I mean, there's a lot of people that grind slower and they don't use these belts. They'll use different belts that perform in those ranges. So anyway, I'm going to see if I can get up to 5,600 with that 6-inch wheel. Also, I've ordered a 3 horsepower motor with the same 56 frame on it, and I'm going to try that out, see how that does, see if it will let me double speed that with a 4-inch wheel on the, if I can double speed with a 4-inch wheel on the 3 horsepower motor and get good top end power. That might be an interesting option there, because then I'll get up around 7,400 surface feet per minute with a 4-inch wheel. See how that goes. That's on order. My VFD will handle it. That's a K-back 29, so it'll take 3 horsepower. This is an all aluminum frame. It's not super heavy. Heaviest part by far is the motor. I picked it up with one arm. I mean, I hooked my arm through there and I can pick it up with one arm. I'm not a huge person. Some of the feet, this is a new thing. What I had been concentrating on for the last year plus a little bit was this tiny motor. And then I've got all of my frame tested, and I'm real happy with the components and the performance of the frame. And so I'm not quite done with the drive wheel design on the tiny motor. I'm still tuning it. It has a little resonant vibration which causes some noise at around 18,000 RPM that I would like to see if I can design out. And so that's still in work. I'm going to have some custom wheels ground that are balanced for 24,000 RPM. See if that's going to solve the problem. I had been making my own wheels, and I can't manage the precision that I feel is going to be required to get that vibration out of there. So I've got this is mounted on a steel sliding mount. I mean, the motor can slide back and forth, make room. It'll fit different size motors. If you have this foot, have a foot on there, it'll fit on a variety of different size motors, and you can adjust it back and forth if that's required to get the motor placed where you want it to be for the geometry that you're looking for. At the moment, it's well, I've got it wired for 220. So if you wire this motor at 110, it'll deliver a horse and a half. Put it on 220, it delivers you 2 horses. And like I mentioned earlier, it's at 3600 RPM. Everything about this is real simple. The goal for me was to not do things that did not add performance or real value to the operator, to the knife maker. It's kind of a no-nonsense machine. I would put this machine up against pretty much anything else I've seen so far. One of the things it doesn't do yet is tilt. There will be a tilt model in the future. This is an Oregon blade maker Platen, and you can see the difference here. They've put just a regular grade 8 bolt in there. On the back side, they've put a locking nut, and the reason they did that is obviously so that they can get the bolt axle rigid and tight without compressing the bearings. Take a look at my solution for that, making axles. What I'm doing is using a shoulder bolt. So I've got is a shoulder bolt that goes in and it bottoms out right there. That goes into the hole and then it bottoms out. And so it provides a rigid axle without compressing the bearings and causing the bearings to develop excess heat. And so you just tighten that in, and I mean it's snug and tight. It forms a rigid solid axle without any compression on the bearings. I use a shoulder bolt in there, and when I got the Oregon blade maker Platen assembly and I put it on my arm, I used a shoulder bolt there as well. Loctite those in, that way they don't vibrate out. The tracking mechanism is extremely simple. Just this little block here that pivots. Again, it's on a shoulder bolt so that you got smooth hole on a smooth axle without any threads that are cutting and vibrating and wearing the holes excessively. This is a pivoting plastic foot, nylon foot, that rests on there and always keeps it adjusted. You're not marring or messing it up. And the weight of the belt obviously keeps that down. On this side of the adjuster, got a cast iron handle with a grade 8 all thread in through steel threads. All these inserts you see, those are steel threads. Steel threads. Everything is steel threaded. I don't have anything into, only thing that goes into aluminum threads is this thing here, and this is the piston, gas piston. It pops on and off those balls. I've got a 60 pounder on here now. I had an 80 pound earlier. This motor didn't like the 80 pound. My little tiny motor loves the 80 pound gas spring. So I had a 40 on there for a while. It did well also. I think the 60 did a little bit better than the 40. We got a handle up here, just a piece of bar threaded on. Those are bolted on. It's very lightweight, but it is very rigid. One of the things that one of the comments or critiques that I had when I built my first aluminum frame and was bragging that it weighed less than one of these motors. It weighed in at 48 pounds. And they're like, "Whoa, it's too light. You need all the mass in the machine to dampen down vibration," and that's a bunch of crap. I don't know how else to say it. You don't need all that in there. You need if you're getting really bad vibrations in your machine, then your design is poor, your construction is poor, your wheels are out of balance, something's not running right. If you're getting a ton of vibration in your machine and you feel you have to have a 250 pound machine to dampen that down, then your build is poor in some way. Either your design or your manufacturer is poor. So that's a myth. If somebody's telling you that, or if you're believing that, or you're thinking that, it's a myth. It's just a crutch for a poor design. Alright, I'm going to get off that subject. The heart of the machine, this is something that I'm the only one doing. I don't think I haven't seen anybody else making an aluminum frame yet. And definitely I haven't seen anybody doing a bar inside of a tube kind of a thing with this kind of tolerance. Alright, now the majority of everyone else that's making machines, they're doing the set bolt method where you turn a knob and a bolt goes in and stabs the bar somewhere and that locks it in. And I've seen some of those and they have quite a fair amount of gap around their bar. You can see mine's loose. Extremely small amount of gap. Extremely small. I mean, I don't have a feeler gauge on me, but there's probably 15 thousandths or less gap in there. Alright, what I got is two 12 thousandths pieces of plastic. Yeah, so a 12 thousandths piece of plastic goes in a ways from the edge. So it's between I'm just estimating it's between 10 and 15 the actual gap in there, and you can see it slides really easy. As soon as you clamp it up, it doesn't go anywhere. Release it and it moves again. And when it clamps up, it centers it and automatically tightens it, so each time you close the clamp, your bar and your platen and whatever your wheel, whatever you got in there, is going to return to the same position it was previously. You don't have to worry about, oh, I've got to clamp it in this method and clamp it in this method and put a shim under here or push down on that or lift up or try to manage your gap in any way to be sure you get everything in the right position. This machine is designed for fast, repeatable setups. For me, repeatability was very important. I wanted to be able to repeat what I did on one side of the blade on the other side in the shortest amount of time possible. I enjoy making knives, but I don't enjoy standing in front of the sander longer than I have to. Alright, we'll do some running on this. Put a belt on it. This is a tired old yellow belt. It's ground. A couple dozen knives on it. Tracking. I always like to check the tracking before I get going. Safety glasses on. These handles can pull out and move around if You want to get them in, if they're in the way, you can move them out of the way. I'm going to go fire it up. Got it on 3600 RPM is the top belt motor, or is the top motor RPM, and that'll give us about 4,700 belt speed, surface feet per minute. Top speed right there. It's not bolted down. You see it's not vibrating, not making a lot of noise. It's on a wooden table that was actually making more noise than it would if you're bolted down to a bench top with maybe a piece of rubber underneath it or something. You see it's not bolted down. I mean, got real good power with that wheel on there at 3,600 RPM. I don't like the top belt speed personally. It's not a bad speed. I mean, it's not what I like to work at. The guy could grind with that without even bolted down, really. That's my practice blade. Got little sway heads on there. The injection braking activated on there, so in about 1.3 seconds, when you flick the switch to stop, it stops. Bang. So I prefer that. I don't like it to just coast down. Sometimes I want it to stop. I'm going to change belts. I'm going to do something else. If you don't use the injection braking, runs down like that. So if you got it at a belt speed that you like, and you don't need to make an adjustment, you just hit stop, belt stops, make your change, do what you gotta do, hit start again, right back up. Let's see, what else can I show about it? I'm excited to try the 6-inch wheel. I think that'll make it an actual machine. Make it a 6-inch wheel, it'll be an actual machine that can get some work done. At the moment, it's just not a machine that I would be interested in to have a top speed of 4,600. I started out with a 5 horsepower motor that ran at 7,300 feet per minute. I've got that 3 horsepower spindle motor with the tiny drive wheel that runs at about 7,200 surface feet per minute. So I'm really used to that. I like taking off metal fast when it's time to take metal off. Like doing the initial bevel grinds and stuff like that, when you just rip it off in just a matter of a minute or two, instead of taking longer. This is hollow. That's a lightweight thing. This is 1/4 by 1/4. I also use a lot of solid. Got solid ones as well. They're just as good. This was laying around. I have a bunch of both. This was laying around. It's easy to make one. And for the Platen, it is very rigid. It is more than rigid enough to do what it's got to do. I have never encountered any trouble with flexing from these hollow 1/4 inch wall by 1.5 inches in this application here. Now, when I'm doing a bevel guide, I've had some flex in those, and so that's where I generally use the solid, is in when I'm attaching the bevel guide out here, and so it's even more rigid. So we'll take a look at the tracking. Wore out old belt. Alright, that's a wore out belt. Like I say, I've done a few dozen knives on this. I grind edge down and I get dozens and dozens and dozens of knives ground per belt that way. I've got a belt over there that's ground more than 50, and this one's ground more than 30. Yeah, I have a hard time wearing them out. I mean, they keep grinding and grinding, and generally the failure that I have will be in there. A lot of times if they're just start to, get the edges damaged or worn, and so they're not tracking good for doing the clean cuts and things like that, I'll use them for doing other projects until they end up breaking. I grind a lot of stuff, metal, mild steel, aluminum, fabricating things. I even grind wood once in a while. So when these are not suitable then for knife making, they're more than suitable for tearing up mild steel for quite a while in their life, when you're not doing anything fancy or nice like cutting bevels or plunges. If you're just grinding down some metal, these belts that are a little bit out or a little bit worn will shred the mild steel big time. So I don't throw very many belts. I don't throw belts away at a very fast rate, is what I'm trying to say. I mean, they get really worn before they go. We'll put on a new 120. This is a Cubitron 120. Good grief. I'm on the wrong side of this for the camera on purpose, making it difficult. Alright. Now I generally run with a safety guard that comes up here, a belt catcher. And on my other Platen I have a belt catcher down here as well. It's really, in my opinion, an important feature when you're running at the speeds, up to 7,000 and a little above 7,000 surface feet per minute, to have a belt catcher. And I don't like to stand in line with the belt when it's going at those speeds. I work from the side with my bevel guide, and I'll be on the other side and work that way. I don't stand right in front with my head down, doing that. I stand to the side and work here, then I'll go around to the other side and I work there. I did have one break once. I was standing to the side and my shoulder was in line. I was doing some adjustments, it's about 2 years ago, on an old machine, a steel frame. Had my welding jacket on, and I turned it up and tracking went off. It caught back in the back, ripped the belt, and the thing came off at 7,300 surface feet per minute, ripped up over there and slapped down across my shoulder, and down my shoulder blade and left a red mark on my shoulder and my back through the leather jacket and a flannel shirt and a t-shirt. And I did, a year ago I saw a picture of a guy that got one of these in his face. And yeah, he had a 2-inch wide stripe up his face, across his forehead, and on top of his head a little bit there where he didn't have any hair. He had hair, well, he didn't have hair before, I mean, he didn't rip his hair out, but yeah, he had a close encounter that he probably regretted. Alright, so let's check the tracking. This is a new belt. It's tracking real good. Let's try a 40-pound gas spring on there. And we'll try an 80-pound too. Alright, so we dropped from a 60-pound spring to a 40. Alright, we'll try an 80 just for while we're here. Now you can hear that. A lot tighter. My little drive really likes this 80 pounder. A little one fired back up here before too long, and I'll have this one going. And we'll do some side-by-side testing. We'll test different wheels. We'll test 3 horsepower motor, 6-inch wheel, 3 horsepower motor, 4-inch wheel, and then on this one, it's actually this is a water-cooled unit. I ordered the same motor, only it's an air-cooled model. It'll be a little bit louder because you got the sound of the fan and the air moving through the motor. So we'll test that. So there's going to be it's going to be a pretty comprehensive series of motor testing, testing different motors, different wheels, different drive configurations. See what produces power where, so that I know how to advise someone for their particular grinding style. and then I can tune my machines to deliver what I needed to deliver for each person based on their interests. This one is very interesting to me still. It started everything, and I proved all the frame components on there, and I proved the motor, I proved the drive works good, or durable, long lasting. A lot of guys, a lot of makers said, "Oh, it'll never work. You'll burn out the motor. You'll burn out your VFD." Hasn't happened yet. Been using. I used the original bearings that were on here, and they're still on the wheel that I took off when I replaced it with a different wheel, trying to get the balance thing worked out. The bearings, I haven't wore out a set of bearings. What I did wear out was two wheels. The first, the first two wheels, the shaft in the bearing was 1/1000th undersize, and I thought that would be okay. I put some Loctite in there, and it turns out it's not okay. Even 1/1000th undersize in the bearing, they just beat it to pieces. And I actually, on another one that was undersized by the 1/1000th, I TIG welded the bearing. I TIG welded the bearing to the drive wheel shaft so that it wouldn't flop around, and it put so much stress on it at 24,000 RPM that the